Okay. Hello everyone. Welcome to another episode of Bill Sunday. In the first episode of Bill Sunday, we have talked about um how we can use OpenAI APIs or any other models API and build a chatbot out of it. And in that, we didn't build a simple chatbot. We have built a chatbot which has a lot of specifications, like it has memory, it has streaming, UI effect, and we added error handling and all this sort of things. And like within lecture, I have shown you that how we can use open source model as well, because in the previous lecture, in the episode 1, the OpenAI API did not work. That's why we have used Ollama. That is the open source LLM model which we will be using later on moving forward. And let me tell you this, we are starting episode 2 and we will be talking about one specific concept. But before that, just for clearance, just everyone is on the same page, I'm just repeating the words which I have said in episode 1. When we talk about large language models in the market, there are three types of large language models. Number one, proprietary model, completely closed. You can't see the data set on which this model are trained upon. You can't see the code base of these models. You can't see anything. What you can do is you can just use these models. And what are these proprietary models? Examples are GPT, all GPT models, right? Claude, like Anthropic is a Opus, Cloud Opus 3.5, whatever. I can't remember. Like there's a Mythos, right? Mythos is also a proprietary model. Similarly, we have Grok and all these things are proprietary model. Now the second category of models are uh, open source model. When I say open source, what I mean by that is that you can see the code base of that particular model. You can see the data set on which these models are trained upon. Okay, these are open source models, and the example of open source model, we have a lot of like Chinese model, like Gwen. Some models of Gwen are completely open source, right? These are the examples. Ollama models, like old initial version of Ollama models, are completely open source model. Similarly, the third category of models are open parameter model. What I mean by open parameter model is that, listen, there are two things whenever we talk about LLM. These two things are really crucial. One is the code, like the entire code base, whatever, how the model has implemented each and every nuance. You can see that in the code base. Okay. The second is parameters. Parameters is basically the data set. I'm just telling very roughly that the data set on which these models are trained upon. These are the two main important things that we have to consider every time. And when I speak about the third category of model, what I mean by this open parameter model is that we only have access to the parameters, the data set on which this model are trained upon. Like Teams is detecting the like, that's why it's showing. But yeah, open parameter models are the models for which we know exactly the parameters, but you can't directly see the code base of it. And the examples of open parameter models are llama, 8 billion model, 3 billion model, right? Ollama, most of the Ollama models are open parameter model. DeepSeek, I think it's, if I'm not wrong, it is also open parameter model as well. I think DeepSeek is an open source model, right? You can access the code base, you can access the data set on which these models are trained upon, right? So these are the three different models that we have, and this is really important. This differentiation, this understanding of three different models is going to be the most important thing moving forward. That is why I keep on telling you guys that we should have a complete understanding of LLMs. Okay, now let us talk about the Build Sunday episode 2. What are we going to do in episode 2? We are going to build a rack system. That is a simple thing. And what rack system? I don't know what rack system we are building, but my goal is to make sure that by the end of this episode you are in a condition where you know exactly what is rack, what are the different types of rack. Again, rack is a very big concept in itself, so we can't cover everything, but we'll cover very simple concept of RAG. Like if you take the most, like again, like they are like there are different types of RAG, but I want to focus on the basic type, and we will understand what is this basic type, the very simple version of RAG, and what are the different components, what is the actual meaning of RAG and all these things. Okay, so let me share my screen and let's start our session. I don't know why Teams is lagging this uh, sometimes. Okay, so I have optimized. There are so many tabs which is open right now, but I have my PPT. I'll cover PPT, and whenever I find that something is really important, worth giving time, then I'll go to Whiteboard and we'll talk about that there. Okay, so in this episode, we are going to build RAG from scratch. First of all, let us talk about what is the meaning of RAG. The full form of RAG is Retrieval-Augmented Generation. Okay, let me directly go to Whiteboard and I'll come back to PPT. This is my like very bad habit per se. But first of all, let us understand what is RAG and why RAG. So when we talk, let us begin with first of all, what is RAG? What is the meaning of RAG and why do we even need RAG concept in development? Okay, so talking about what is the meaning of RAG. Okay, imagine that you have LLM, okay, and you have database. This LLM, any LLM you take, right? Any LLM like ChatGPT or DeepSeek or Ollama model, they are trained on a specific set of data. Now imagine that you have different type of data. Let's say you have your own company and you are building like AI app for your company. Okay, let's say the another example is you are building a medical application. In this case, if you are building something for your company or if you are building something for medical world, the most important thing is accuracy. You cannot compromise on accuracy, correct? So what we can do, we can exactly gather the data, right? If I'm building a medical application, I gather the medical data, I have my LLM, and the RAG is a system where we are telling the LLM that whatever you are doing, whatever the query you are doing, you should not use your inbuilt data set. You should go ahead and look at the external data set which is attached, the external knowledge base which is attached to it, right? This entire concept is known as RAG. So let me write it here. The definition of RAG is that building a I'm just writing very basic definition. So building BUILD, building a AI application where LLM is strictly, right? Strictly, I'm writing strictly because we create RAG applications for this reason only, because we want our LLM to search in the database which we have created, not anywhere, not in its own database. Okay, not in its own parameter. It should go and search in the external database. So where LLM is strictly what I can write, strictly programmed, strictly instructed to give answers on based on the knowledge base, based on the knowledge base we have created. Okay, this is the meaning of, let me just make it, okay, you can see on screen I think now. Yeah, this is the meaning of RAG, that you are attaching an external database and you have the LLM, right? In previous application, what we did, we asked a query and LLM did its own thinking and give answer. But here we are explicitly removing the thinking part. It should not go in its own parameter. It should first of all go to the knowledge base which we have created, and based on the information which it gathered from the knowledge base, it should give answer. This entire system is known as RAG. Why do we need it? As I said you that if you are building an application, a critical application, where accuracy is really important, where accuracy is really important. For example, you are building a app for medical world. You cannot be wrong in that thing. If you are wrong, then you are risking someone's life. Are you getting me? Right? So that is the most important thing. When accuracy is must, then in those cases RAG is considered to be the very best option and cheap option as well. So let me go back to, I hope you have understood that what is the definition of RAG and why do we need it, why do we use it at the first time, right? Let me, like, before we go back to PPT, I just want to show that we have LLM. I'll draw diagrams now. I'm mad about diagrams. Okay, so we have our database, right? And I'm calling my database in AI engineering language. We call our the database which you are creating is as knowledge base. Okay, I have my knowledge base. Now what happens is that in knowledge base I store, let's say, just imagine that, I know, like, we are going again some parts of theory, but I'm not gonna speak. I'll speak for 1 or 2 minutes and then we'll go back to implementation again, because this is build Sunday episode. So let me just explain what is happening. Okay, so imagine that we are building a healthcare application. Now when we are building a healthcare application uh, for doctors or for patients, we are providing uh, knowledge base, or we are providing data, a database where the data which is stored in this database are medical documents or medical related information. And you can say, like, a database is nothing but a place where you store data. Now imagine that you're creating a, like, your database, and I'm talking about medical application in specific. And in this, what we are doing is we are storing the, like, data of medical papers. Let's say whatever the research papers which have published from 1990s to till now, I have stored all that in my database. Okay, clear? Now when query comes in, when query comes from user, we will not go directly to the, like, I'm drawing here, will not directly go to the, I'm writing X here, will not go directly to LLM. And LLM has its own parameters, LLM has its own data, will not let LLM use its own thing. First of all, we will go to the knowledge base which we have created. Okay, we'll go to the knowledge base which we have created. And what are we storing in our knowledge base? We are storing medical related information. So from this medical related information, our query will get processed and we'll do some similarity search, we'll do some searching, sorting thing, which we'll be talking in detail when I go back to PPT. After that we'll build the application. Okay, now here we'll go back to our knowledge base, we sort out things and we retrieve the similar documents, the relevant documents, right? And after that we give it to LLM. Okay, we give it to LLM. And here what we are doing, we are giving query, query plus the data which is retrieved, the documents, or in the place of data I can write docs which is retrieved. Okay, whatever the document which I have retrieved, the research papers which I have retrieved from my knowledge base. Okay, I am giving that and query to my LLM. And this thing, this complete thing is known as let me write here with a different pen, of course. Okay, so here this thing is known as context. This is known as context of LLM. Context is basically, the meaning of context is you're providing additional information instead of just a query. And what is this additional information? User query, we give something called as prompt template, and we'll also give the retrieve documents. Okay, I will talk about what is prompt template and all those things, but yeah, this is the thing. Now what happens is that when this query gets in, we give answer. Now we give answer to the user. Okay, whatever the query he has given, let's say this is our user. So this is our user has sent a query, and instead of going directly to LLM, we will go like this, and we'll get the answer. So the thing you should observe is LLM is not using its own brain. It is using the knowledge base which we have created. Because of this, the accuracy will improve a lot. I will talk about like why we are not using the database of the LLM. Okay, so this entire thing, this entire concept is known as RAG, and the full form of RAG is Retrieval-Augmented Generation. I hope we are clear till now, right? This is theory. Now let's go back to our PPT. PPT is the same thing, like whatever I have explained, I have written in PPT as well. So why do we need it? The reason is that I have told you, right? LLMs are trained upon datasets. And what are these datasets? This is really important. The datasets on which LLMs are trained upon are internet data. And internet data is often unstructured. What I mean by unstructured, okay, on internet you will find shopping related websites. On internet you will find movie related content. You will find education related content. You will find medical related. So when internet scraping happens and you create data, it's not one particular data, it's a combination of data, right? It's a very like combination of like movies, culture, literature, all this physics, math, all this thing. You're creating a bundle and giving to LLM. When you have abundance of data, the probability of hallucination is really like high, right? Models hallucinate and might give wrong answers, sometimes might give false facts. Okay, that is the reason why your LLM will not know your data. Like when you give what is Q3 written policy, it might not know, because you are building the application for your company. And how can LLM know private company data? Because it is trained on internet data. Are you getting me? Right, that is one thing, right? And hallucination is another. After that, false like facts is also a thing. So that is why we can't directly, when we are building AI platforms, AI applications, we can't directly attach LLM, right? We have to go through this rack process. Okay, now the solution, as I said, that whenever a question comes in, we retrieve documents from the knowledge base which we have created, and then we give uh, that to the LLM, right? That is the injection process. We are injecting our documents to the LLM and LLM will generate the answer. Okay, now there is one more thing. Like in AI engineering, there are three terminologies which you will be keep on hearing again and again. This terminologies you will hear, I think, for next 5 years, which is RAG. First one is system prompt, or you can say prompt engineering. Second one is RAG, and third one is fine tuning. Okay, let's I have made a separate video talking all these three in detail, but let me tell you this. In RAG, what we do is that we like attach a external database, and this database can be changed. Like let's say I have added 10,000 research papers in my medical knowledge base. Now in 1 year, again researcher has published 100 new papers, so I can easily take that, insert that in my database. It is very easy to do that, and the cost of RAG is also really low. Like you don't have to maintain, all you have to do is maintain a database which we call as vector database. After that, again the transparency is really like you can tell exactly from which document the answer is coming. Let's say you have 10,000 documents, you have sorted this 10,000 documents, you can exactly tell that for this query the answer is coming from 10 documents, 10th document. Like this you can exactly tell. And primary uses like fact retrieval and grounding and all that. Okay, now what is fine tuning? As I told you that LLM and LLM are trained on internet data, and this data set, right? uh, okay, again, like to understand the process of fine tuning, I need to explain one more concept, which is parameters. Every model has a parameter, and parameters are responsible for giving correct answers. Okay, now imagine that, okay, I don't want to go in parameters and all that, but here the thing you need to understand is when you fine tune a model, right, the data we are we are having a model, right? And for this model, we will have a data set associated with it, and we call this data set small data set as known as parameter. We call this data set as parameter. Now this data is fixed, right? And we train the model. In the training period only you can add. After model is deployed, again again inserting data is not possible at all. That is why static and frozen at training cutoff. You can add data in the training period of model, training period of fine tuning, but after that you can't. And this process is really high. Like sometime I'll make video about fine tuning in detail. Right now this video is about track, that's why I'm not going there. I don't want to make this like video for a like 1 hour 2 hours long. Again, we have in-depth series going on. That is a long series. I don't want to make this long. Okay, so this is a very high process. You need to have servers, set up all those things, and you can't exactly tell that from where answer is coming in. Okay, and here what we are doing is, when I say that I'm fine-tuning a model, I'm changing the internal behavior of model. This line is important. Through fine-tuning we change the internal behavior of model. Again, we'll see what is fine-tuning and all that in detail, and how exactly we change we'll see in upcoming lectures, but for now just understand. Okay, now let's talk about the application which we will be building. In PDFQA we are building a system where user comes with a document. Okay, now user uploads the document, and when user uploads, we take the document, we extract the text out of it. Okay, and after that we create semantic chunking. I'll talk what is exactly the meaning of semantic chunking and all. And after that we embed these chunks into the vector database. Okay, and then whatever the answer query comes in, our answer goes through this cycle. Okay, now uh, okay, let's not directly go to PDF. Let's not just talk in PDF. Let's come in Whiteboard and discuss for 10 minutes and we'll go back. Okay, here let's go through user flow, and while going through user flow, let's tackle the technical aspects. Let's see the technical aspects as well. Okay, now I'm changing this to black only. Okay, so here user uploads a PDF. Okay, now internally what happens is, this is step 1. After step 1 we take this PDF, we take this PDF and extract the text. Extract the text. Okay, now here let me show you one example. I want you guys to follow up with me because it's gonna be really interesting. Okay, now PDF examples. I have a sample PDF. I don't know what it is and all. So you can see this is a sample PDF, lorem ipsum, whatever. Now, thing is, when user uploads, inside that we have text. You can see this is text. This part is text. The question is, how you gonna extract that text? To extract that text, we use, I'm writing the tool which we are gonna use is Python libraries. They are specific built on libraries in Python which will be responsible for extracting text from the given PDF, from the provided PDF. So Python libraries like I think PyPDF, and let's see, I have mentioned those in my PPT as well. You can see like PyMuPDF, PyPDF2. These are the two libraries which we mostly use. PyMuPDF. These are the libraries which we use to take, or you can say to extract the text from the given from the given PDF. Okay, now after that what we do, like here you can see, if you observe this thing, if you observe this rack system which I have just described, you can see that every query is first of all going to knowledge base, and from knowledge base it is going and reaching LLM. At last it is reaching LLM, right? Now the thing is, if you don't have knowledge base, then where it will go? If your knowledge base is empty, then nothing will get retrieved and zero context will go to LLM, and LLM will not give you a correct answer. So creating this knowledge base is really important. Okay, now here what I'm trying to do is, first of all, I'm trying to create a knowledge base before even a query comes in. Okay, now this is step 1, user uploads PDF. Step 2 is converting that PDF and extracting the text from it. After that we create chunks. Chunks is basically, you are taking around 800 to 1200 characters as a group. Okay, after that let's say in this, let me come back to PDF. Okay, here uh, this is 800 characters, so this will be my group 1, and after this second, this will be again 800 characters will be group 2. Like this I create different chunks, chunk 1, chunk 2, chunk 3, C1, C2, C3 of the entire PDF. That is my step 2, right? Step 3 basically, not step 2 exactly. Step 1, step 2, step 3. Okay, now after that the next thing is converting this chunks into embedding. What do I mean by embedding, Jabir? What is embedding? You're talking a lot of difficult words now. Let me explain you this. LLM does not understand words. Any LLM, right? They don't understand words. What they understand is, they, like when you are giving, let's say I have ChatGPT, right? In ChatGPT I'm giving any, like a prompt that, okay ChatGPT, my name is Jabir Hussain. What it understands is, it will not understand English, it will not understand Telugu and all that. It takes words, right? Hey, my name is Jabir. So it breaks down each and every words and convert that English word into equivalent number, and it understands number. Okay, if you don't know how like exactly LLM works, I have made a, I think 1 hour, 1.5 hour video. You can watch that on YouTube. It is available on YouTube, I think. You can go ahead and watch that. So LLM understands only numbers. That is why what we do is that we take these chunks and we convert these chunks into numbers. Okay, at least embedding is nothing but a linear one-dimensional array. Okay, so all these characters, all these words will get converted into a list of character, list of single dimensional array. Let's say if the like chunk size is 800, then we will store 800 words, 800 numbers in a single dimension array, and we call that as one embedding. Like this we create n number of embeddings. Okay, and which tool we use for converting into embeddings? We use a tool, Hugging Face tool, called as sentence transformer. I might write spelling mistakes, forgive me. And this is Hugging Face. Hugging Face tool. This is again a model in itself which is responsible for converting, or you can say tokenization. Tokenization is nothing but converting characters to numbers, numbers to characters. Now what we do is that we take these numbers, we take these embeddings basically, and store it in our vector database. So in AI language we call our database as vector database. Vector database is nothing but a database where you are storing vectors. And what are the vector database we have in the market? We have Qdrant DB, we have Fitz, we have Chroma. Like this we have different uh, vector database. I think in next lecture, in next episode of Build Sunday, we will talk in detail about uh, vector databases. Okay, so vector databases, this is my step 1. So my step 1 is completed, which is knowledge base creation. My knowledge base is completed. Now when user query comes in, what we do is that we take this user query. First of all, we go, okay, let me again go with the user flow as well. Now user has uploaded document, now he's going to ask questions. So when user asks queries slash questions, okay, what happens is that we take that query, and again we know that LLM understands only numbers, so we convert that into, we do tokenization, basically you convert that into embeddings. Okay, now after that what we do is that we take these numbers, go to vector database, vector db, and do similarity search. What I mean by similarity search, listen, this is really important, and what I'm going to tell you, what the concept which I'm going to tell you is known as tokenization. The meaning of tokenization is that uh, when you give, hi, my name is Jabir Hussain, when you give this thing to ChatGPT, what happens is that hi will get converted into a unique number, and my will get converted into a unique number, name will be converted into a unique number, and when words are similar, these numbers will be closer to each other. Okay, for example, let's say dog, the equivalent number, the tokenization number of dog is, let's say, 32. Okay, and puppy is also a synonym of dog. So dog and puppy are basically similar words, that is why the equivalent numbers will be closer, right? If it is 32, then it might be 33, 34, 35, near to 30, 32. Okay, it can't be like 1 million or 100 or 200, so it can't be like that, it will be near to the dog, to that number 32. Are you getting me? Now when we get these numbers, we go through all the documents and we search which document has the highest similarity, which document, let's say the numbers in the query is 32, 45, something like that. We go and search in all documents and see how many times these numbers are matching, and and uh, we will also see that the document which has the highest repeating numbers which we got from query, like just imagine that I got 45, 32 and 20. Okay, 35, 42 and 20. Now we have three documents, I'm just imagining a scenario, I have three documents. Now in document 1, let's say the matches, like the number of repeating are this numbers have repeated 2 times. In document 2 the numbers has repeated 3 times. In document 3 the numbers has repeated, let's say, 10 times. Now you tell me which document has the highest similarity, which document is very similar to the query, the thought document. So I'll retrieve the thought document. Although in this approach there are some flaws, but like right now it is not that much important because we are building very basic application. Okay, so we like do something called a similarity search, and to do similarity search, the tool, okay, I'm writing here, the tool which we'll be using is cross encoder. Again you will find this cross encoder model in Hugging Face as well. Like all these are open source models. Okay, now after retrieving similar document, we have something called a system prompt. System prompts are basically the instructions which tell LLM that you should not use your internal database, you should not use your internal brain and all that. Use only the thing which is provided after context or query, plus the retrieved documents. Okay, and we call this entire thing as context building for my LLM. Okay, I hope you are getting what I'm telling here. Okay, this is known as context. Now after that we will touch my LLM and LLM will generate answer. This is the thing, this is how the user flow works for our application. This is the architecture of our application. Now let me quickly go back to PPT and uh, start from the current slide. So you can see PyPDF, I have told you, like text chunking and splitting. We talked about tokens, retrieve position and efficiency, and embeddings. Embeddings are mathematical representation, and as I told you, like vehicle concepts, feline concepts. So whatever the concept, let's say this words represent dogs, then all these numbers will be near. If this line is representing cats, then all the words related to cats will be near. This is the meaning of that. And how similarity search work? The search space, query matching and all that. And yeah, top matching things will take from the document. And yep, embeddings, vector search, top retrieve k documents and assembling them and giving to pipeline. So this, we call this as our retrieval pipeline. Okay, now uh, we give grounding responses, context ingestion. Basically, this is system prompt. You are a helpful assistant. Use this to answer the query and all that. And this is the like, as I told you, it removes hallucination because our answers are coming from credible sources. Okay, now this is the like overall concept. I have talked about the architecture. Now let's talk about the structure of our code and what each file does before we even start coding. I have a prompt, I'll give it to anti-gravity and we'll see how this application works. Okay, now our application name is pdfrag system, and in that we have main.py. Main.py is responsible for calling all the application. It is the entry point of our API. Okay, now document processing is responsible for extracting text, cleaning and creating chunks. Okay, after that we have something called as embedding.py. This is responsible for converting my chunks into vectors. Okay, after that vector store.py, this is known as this vector store uh, is responsible for storing my uh, data vectors. Whatever the vectors I have created, it is responsible to store that. And after that we have retriever.py. This is responsible for retrieving documents whenever a query comes in. Okay, and generated.py is responsible for generating output. Simple, nothing like not hundreds of files, very simple application. Now let's build this thing. So this is the thing, let's do building now. Enough talking. Now I have my application. Okay, what I do is that let me directly open the folder. I'll open my folder directly. Okay, build Sunday and episode 2 rag pdf. Now this is my IDE. Okay, now what I'll do is that I'll give the prompt to my AI, to my IDE, and IDE will generate the answer. IDE will generate the code, and I will like you can see, you can say that I'll see at each and every step that whether code is right, whether the exact tools are coming or not, because I know about tools, I know about how this application works. This is the thing, right? If you are a vibe coder, you don't know what is happening. If you are a developer, you know exactly what file is does like doing what is happening in each and every line. This is a differentiating factor that you have to learn over the time. Okay, now let's see the prompt. I have this prompt that I have mentioned specifically. I have mentioned how everything should work and the configuration, everything. Okay, and this is like environment things and all. Okay, and um, PDF plumber and all this thing I have like basically mentioned. Now they are in market. Sorry, in market. One, let me write one more thing. thing thing is that I want you to use uh, Qdrant DB. Qdrant DB is a vector. Qdrant DB as our vector DB. Okay, Qdrant DB is basically one of the type of vector databases. Okay, we'll talk about vector databases in next class, but next build video. But this is This is the Qdrant DB which I have in my computer. That is why I'm using that. Okay. Now I'll open my Docker and I have Qdrant. Let's. It's gonna take my entire storage. So I can quit Chrome or else leave it. Leave it. If recording has stopped, then I will stop, or else let it be. Okay. So you can see in Docker, I have downloaded my Qdrant DB. I'll provide you a video of how you can exactly download Qdrant DB if you don't have. Okay. So Qdrant vector database. This is my Qdrant vector database, and the link of this is. Let me click on it, and you will see that Qdrant is running, and the link of Qdrant is image containers and all, and the port where it is running is localhost 6000. So I'll just write localhost 6 in this thing it is running. So okay, so you can see this is my Qdrant vector database. It is running. I will open up. You can see this is my this is the interface of my Qdrant vector database. It is taking time because I think it all this are taking so much of space. Close. Yep, you can see I have different things, different points and all that. These are my personal and work related projects, but yeah. Now I have Qdrant. I'm giving a specific prompt that I have Qdrant. Let me put teams here. Qdrant running at this. Okay, and this please use this and use Ollama 3B model as our LLM, and make sure we are not using any third party, because from now on we'll be building applications from the open source model itself. Okay, I have Ollama. You can see I have Docker, Ollama, all these things are running here. Okay, third party LLM models like OpenAI and all, and use sentence transformer for embeddings and all. Okay, I have given the prompt. Let's see. So what we will do is that first of all, we will read the entire prompt and we will create the code. This is the thing. This is how everything will work. Okay. And while it's doing its work, let's download a sample medical related information, because we have started our concept with medical data, right? So medical related PDF. Standard treatment, essential internal medicine. I don't know what it is. I'm just opening up because I don't want. Oh god, this is a big book. We don't wanna waste time because it will go again 1 hour. Let's do one thing. Let me close this tab, and I will be providing this document. This is a really useful document. Different types of embeddings, right? They are text-based embedding, they are image-based embedding. I'll provide this document. You can read it out. In the description, I'll give it. In comments, I'll give as well. Patient-related PDF. Let's see. Pondicherry University. Again, I don't want, like, let's give sample patient, sample written history and physical examination. Okay, you can see this is 6 pages document. So let's download that first. in our system. I'm downloading in desktop. Save. Okay. Now let's see what is the condition. Yep, proceed. You can see document py printer raw text Qdrant DB query generator cosine similarity citation. Yep, proceed. It has given me architecture and everything. So I will start building now. I hope we'll not get any errors because the sometimes like PDF this tool PyPDF is not that much compatible with Mac. So I have to give permission. And you can use different models as well. I don't have credits here. Okay. Let's see what it is generating. It has generated me ENV, my Qdrant credentials, embedding model credential, which is sentence transformer, um, Ollama running, and which model we are using, and what should be the chunking and overlapping size. This concept I forgot to tell you, right? Okay. Let's say I have chunk 1, I have chunk 2, I have chunk 3. Now, what if I'm dividing my chunk in 500 characters, right? So let me take a sample PDF. Okay. Now, just imagine that I have started here and my 500 letter ended here. So you can see that this onset is a complete word. But the thing is that even though onset is a complete word, my 500 word ended at n. That is why chunk 1 is a separate thing, and this set over all this like this, chunk 2 will start, right? So when AI sees, when anyone sees, they think that okay, why there is a this particular chunk is not having any meaning, why it has ended with on, and why it is starting with set, chunk 2 why it is starting with set, it doesn't have any meaning, right? So to have meaning, the both chunks has to overlap, and when they overlap you'll understand, oh, the sentence has breaked there. Like now it makes sense when you see the overlapping, the combined picture, it is making sense. But when you're seeing like discrete pictures, they're not making sense. Are you getting me what I'm trying to say? That is why we add something called as overlapping. Overlapping is nothing but the words, like let's say chunk 1 has ended till here. Now for the next 50 words will overlap, okay, and then the next chunk will start. So this is my chunk 1, this is my chunk 2, right? So chunk 1 will be like 50 characters above chunk 2. It means that this two will overlap on each other, such that to maintain meaning, the maintain consistency. Okay, this is the meaning of that. Yes. Okay, now top K is basically how many documents you're retrieving. Allow. It is doing the testing itself. Okay. Top K documents is basically how many documents you are retrieving from the model. Okay, our application is ready now. So let's see how we can run our application. This is the thing, prerequisites, Docker should be running, Docker is running. I hope we'll not have any problem in running the application. Okay. Do we have UI? I think we don't have UI, so I have to uh, insert the document. So what I'll do is that I'll just see within console itself, our application will work. Or else should we create UI? It is easy, but for now, let's keep it simple. We'll run everything in console itself. Okay. Now, my terminal is running. This is my terminal. Uh, what I will do is that I will first of all set up document, right? I'll open my terminal, and in terminal, uh, let's see what we have here. This is build. Step 2 is build. Step 1 is upload documents, usage guidance. Okay. Mm, let's take our sample document. Okay, where is our sample document? I think where I think it's in downloads. So downloads. Okay, and which one is it? UN report, right? So it's not in here. Mm, where is it? Have we downloaded the report? Let's see. I mean, yep, it is here. Where is it? It's in desktop. Okay, it's in desktop. Okay, Mm, desktop. Am I that much of a blind person? I can't even see. Oh, yeah. Sorry for the delay. Okay, we have a document pasted in within the repo. Now, here we will follow the running. So prerequisite Qdrant should be running, Ollama is running, installation we have installed, Qdrant is configured, usage, upload the document, drop one or more document in data uploads. So where is data? First of all, there's no data. So data upload. Step 2, build the vector database, and then step 3, start interactive, all these things. Okay, let's do one thing. Can you give me run commands? Give me run commands for the application. Or else let's do this. Okay, let's do this. Right? Yeah. Okay. Yep. So it is telling, first of all, Ollama, run Ollama and verify pull is verified. Okay. Setup is completed, I think. So let's do this first comment, first copy this. Okay. You can see our installation has started. Now, the thing is, I think Ollama 3.2 is already in my computer, so I don't have to pull it. If I copy this, then it will show that there's already model downloaded. So I'll just show you that. And after that, run the application. So build recursive uh, and src main.py and this ask questions, QA related questions. Data uploads. Where is data folder first of all? QAB, LIB, bin. This is virtual environment. This is thing. So let's wait. Okay. So the requirements download is completed. Let's see Ollama model is present or not. I think if okay, pulling manifest. I think it is pulling. Yeah, it is already there. Now, I have like let me tell you in the meantime what I did. I have created data folder, in data folder, upload folder, and I have uploaded our PDF document. This is our PDF document, which we downloaded from internet, and vector DB is right now empty. Now what I'll do is that I'll run our commands here. This is the commands and click enter. Uh, okay, why is this thing? Okay. Control V, and let's see why we are getting this thing. Okay, let me like copy individually. Okay, so this is recommended, like first option, like we're just creating chunks and inserting that in our vector DB. You can see, uh, let me put this really big. Yep, you can see like it is stuck, but internally I believe it is doing work. And right now uploads pay one folder and vector database is empty. But when this terminal process gets complete, I think we'll get something in vector database as well. So let's see how it works now. Okay, the chunking is completed. It took me around 5 minutes, something like that, or yeah, you can see that I have added like pdfrag, pdf name is yuan pdf and all. So let me just close, and yeah, now let's run the application. I hope it will run now. Okay, so like our application is working now. I can ask question like what are the like things described, what are the things which are described in the document. Let's see, I have two documents, so documents, semantic lookup, you can see it has generated like retrieved from this chunk, retrieved 4 matching chunks, and it took this thing, and it is giving me answer still, I believe. Right, let's see what it gave me. I can't provide a comprehensive list of descriptions from the document as it requires human interpretation and analysis. However, I can provide some specific finding mentioned in the documents. So it is giving me like this, and this thing is known as streaming effect. So yeah, like I want you to observe at the last of the terminal. So this is pretty much it. Like this is how our application works. The reason why you have seen the cuts is that it took me a lot of time to run the application because my system has become really slow. Like there's no storage at all. So this is pretty much it. You can see like it is giving all the patient's burning sensation twice a month and all these things, which it has observed exactly. Like it is also telling which page, which sentence and all that. So this is the advantage of RAG. Okay. Now, you can find this code base in GitHub, build Sunday repository. You can find that, and if you like my work, you can start that there, and you can use the code base because I have put forth the complete code base for free. You can use it, and if you like it, you can subscribe to our channel or like connect. You can connect me in our social platforms. I'll be happy to discuss. Like what do you want to see. If you let me know that what exactly you want to learn, it'll be much more helpful for me to build as well. So this is pretty much it from my end. In the episode 3 of Build Sunday, we will talk about vector databases in detail, right? What is exactly vector databases, what are the things we use and all that. But for now, this is RAG. This is the first stepping stone of RAG. Later on, we'll explore as we go along. So with that being said, my answer is getting generated. Should we wait for the answer? Let's wait for the answer and we can cut the call. So please note that these findings are based on the provided documents and may not be an exhaustive list of all descriptions mentioned in the text. Okay, answer is generated, and yeah, it took 100 like 9070 seconds to execute. So it's a long time because my computer is slow. But yeah, you got the answer. You can see like question, all the retrieved documents and all the answers here. So with that being said, if you watched till here, thank you so much for watching, and let me stop screen share. I'll see you in the next one. Thank you so much. Bye.